Which of the following position versus time graphs represents negative acceleration? We just looked at in the last example, we looked at D in some detail. So if I sketch something that looks a little bit like the graph in D, and again, this is like an X versus a T, I'm going to use as symbols to represent position versus time. But if I say, hey, maybe it starts out by it's moving kind of slowly, but in the negative direction, then a little bit later on, it's moving more quickly, still in a negative direction. And so I think before I'd like made up some numbers and said, what if the velocity here was like -1 meters per second, and here was like -5 meters per, never mind that slash, there we go, meters per second. And in that sense, if I think about acceleration being equal to change in velocity over time, and if this happened, like let's say this represented like a 1 second going from like this point to here, or no, wait, I think we had it 4 seconds. Let's make it 4 seconds again. Let's make it to kind of parallel the last example. And then formally, to reconcile this with the formula that we have, I'd be thinking about -5 meters per second minus a -1 meters per second over 4 seconds. And we saw there that this turns out to be -4 meters per second per 4 seconds. So we can cancel those 4s, but we're going to have to introduce a 1 somewhere. And we'd get like -1. And then meters per second per second, if you look at like how that works out really quickly, if you wonder like how do you think about that? This is the same as meters per second times 1 over second. That's kind of a rule in algebra, right? If you divide by something, it's kind of like multiplying by a reciprocal. And then it becomes more obvious why this could be thought of as a meter per second squared. So that's what I'm put here, meters per second squared for the unit there. And now I'm going to get rid of this so I have a little more space to work with. Okay. What's another possible answer here? I think E is another possibility. And if I were to graph that, and I maybe got a little less space here, that's an object that was slowing down. And I kind of said before, like one way of thinking about that is that the acceleration is in the opposite direction of its motion. But if we look at that, like if we just draw a couple tangent lines, and maybe I can use some similar numbers and kind of say, like, let's say that here it was going at well, I guess I'm going to change it, 4 meters per second, and maybe here it's going at a mere 1 meters per second because it's slowing down. And maybe I'm just going to think ahead and make the numbers easy and say that between these two dots we're talking about a 3-second interval. Then thinking about A is equal to delta V over T, I would say final minus initial, but since it's slowing down, that final is smaller, minus the 4 meters per second, which was larger that I started with, all divided by 3 seconds. And so that, I think, turns out to be equal to -1 in this case. Meters, since it's 1 minus 4 is -3 over 3 is -1, right? Meters per second squared. So that both of these examples I just made up were meant to illustrate how these two graphs can represent negative acceleration. So again, D and E therefore are the answers. And it's also noteworthy that they are both concave down, which is sometimes a kind of quicker way of identifying answers to these type of questions.